Good evening, students.
Good evening, sir.
Good evening, sir. Okay. Okay, let's get started. So we are, I think, at the end of the unit 12. Right? In the last session, we finished talking about few miscellaneous ones from unit 12. Let me show the screen to you. So from the unit 12 part, we discussed in the last class, we focused on the applied human genetics part, right? I think before that we discussed about the anthropology in designing of defense and other equipments we talked about, correct? And then we talked about applied human genetics part, veterinary diagnosis, genetic counseling and eugenics. Okay, and DNA technology we already covered in 9.1, and serogenetics and cytogenetics in reproductive biology. Okay, the summary I was talking to you, I've shared that with you today on the Telegram channel. Otherwise, the remaining documents I've already posted to you yesterday. Okay, so we are left with now only this part, forensic anthropology, methods and principles of personal identification and reconstruction. So we are going to gain an insight into role of anthropology in forensics, correct? So we discussed one aspect already, that is DNA fingerprinting. DNA fingerprinting in identifying criminals based on variations in our DNA sequences, especially in the regions where there is higher amount of variation, right? Mini satellites, microsatellites, or I briefly talked to you about variable number, tandem repeats. So that is purely based on identifying the variable regions in our DNA. But here we are going to focus more on the, I think in the skeletal context or various features of body. So we are going to talk about different applications or role of anthropologists in forensic sciences. So this comes under forensic anthropology. So we're going to talk about various dimensions related to the forensic anthropology part. Let's begin with brief idea on this concept. Okay, so what is the role of physical anthropology in forensics? Forensics means it is something to do with the criminal investigations, or it is something to do with the legal processes. So we're talking about forensics, or forensics are related to criminal investigations are legal processes. And we are trying to learn about physical anthropology role in forensics. Like, for example, if I have to initiate the idea on this, let's say you want to identify, skeletal system or a skeleton that is obtained or found in a place, in a crime scene, which is badly decomposed or unidentified human remains, parts of the human body. Don't know if it's female's body, male's body, what is the age of it, how long ago it might have died. So all these sorts of things that we need to know in order to solve that crime. So what is the role of physical anthropology in providing clues related to this? Is a question. This concept started during 19th century, okay? And mainly it became popular during World War II and Korean War in 1930s. Okay, so this became more popular in recent times and the recent century, right? So starting with the World War II. So physical anthropology is a very important role in all these sorts of things. But how? If you're asked to write either short note on forensic anthropology, or if you're asked something specific related to this, I'll give you a brief idea, a brief overview on some of these questions. Okay, that had come in the exam before. So we are going to learn principles. How is physical anthropology used in answering these questions? Like what type of questions you would like to answer? Like let's say that you found a skeleton. You want to know whether it belongs to human or is it an animal skeleton. Either you are an archaeologist where you are studying the various archaeological aspects. You want to know the skeleton that you find belongs to an animal or human. Of course, if you find the whole skeleton together, you may be able to answer it easily, but you found only small pieces here and there. How do you know whether it belongs to humans or whether it belongs to an animal? You might be studying some of these aspects in your archaeology classes as well. But here our focus is like what features that we look into to say whether it is human or non-human. Are the remains a single individual or mixed remains of several individuals? Sometimes, let's say, either mass murders or wars, for example, tsunami like disasters, people may have been killed and probably the skeletal remains got mixed up. So if you want to identify how many dead bodies probably were, or remainings of the dead bodies were found in those regions. So we need to be able to identify whether a given component or a bone or any other part belongs to the same individual, or are we looking into parts of different individuals? Answering these type of questions. And most importantly, we see this in some thriller movies, for example, or TV shows, that you want to identify the time of death. How do these investigators come to know about the time of death, or it is approximately the time of death? How did they figure it out? What are the key ideas behind it? And gender. Can we determine the gender from the skeletal bone? Is it possible to look into one of the bones of the body to identify whether it belongs to a female or a male? Is it possible? Age. Can we estimate rough age of the remainings of those bodies? Can we even estimate whether it is a Caucasoid, it's a Mongoloid, and so on? So can we determine the race or ethnic identity of that, remain? So these are the type of questions that forensic anthropologists try to answer. Okay, we are going to briefly get into the details about how are these done. Okay, so this is what the scope of forensic anthropology. What did I tell you so far? Forensic anthropology deals with the role of physical anthropology related to criminal investigations and legal processes. What is the role of physical anthropologists? Given that they have a greater insight into human body shapes, types, specific types of bones, they can help identify, the skeletal components belongs to so and so individual, so and so age group, for example, so and so gender, whether it's a male or a female, or they will be able to tell you whether it belongs to certain ethnic group. Are there any ethnic features or elements that are found in them? Which is becoming a bit difficult these days, but otherwise, this is definitely possible. In the process, physical anthropologists, together with other evidences like archaeological evidences, biologist evidences, and other forensic scientist evidences, they can answer these type of questions that I already was mentioning to you. But how? Now the question is, how do they do it? How did they come to know? Okay, let's look into, I think first I'm going to focus on identifying various components. Like, can we determine the gender? What is the sex of the skeletal components that are found? Maybe parts of it, or maybe entire system. So the entire system, as I was telling you, becomes a bit easier. But what features do you focus on? So here I'm going to dwell into few terms. Basically, we are looking into anatomy of human body, only the selected ones. We are not interested in learning everything here, but the coming units also require you to follow a few terms here. One, I think all the units now we are left with 12. So part of the 12, and the next unit I'm going to begin with is racism. 9.5. Initially, we're going to talk about features, morphological features of different ethnic groups, different races. Okay, there we have to use the terminology. What is this bone called? How is this bone different between a mongoloid and a caucasoid? So some terminology is important. Same thing that we are going to learn in 1.6. Quaternary fossil, or fossil fuels, for example. So not fossil fuels, quaternary fossils of humans. Okay, terminology. In evolution, how our body components changed in several million years. Okay, so same terminology. I think we revisit some of these terms repeatedly, so don't get confused. I'll stop and actually I've selected some videos to show you what bone am I talking about. You don't have to understand everything here. Write few points for each subheading. Okay, so what are we going to do? I'm going to take help of few videos that actually analyze these skeletal components to tell you the differences between males and females, so that we can identify whether the given skeletal component in question belongs to a female or a male. Okay, so how do we determine sex? The first and foremost thing, I think the most commonly used resource for this is the pelvic region of females and males, because there seem to be enough differences in our pelvic bones, okay, which indicate whether it's a male or a female. So what are those differences? How do you know whether it belongs to a female or a male? What are the differences that we are going to see? I'm going to show a video to you on this. Okay, so we are seeing the pelvic structure here, the pelvis here. Several bones are joined to that, and there are spaces or gaps that you find. So basically, look at this. This is the backbone part. The backbone joins here. This is the bone part and continues to the tailbone region. You have a tail-like structure towards the end. How is this placed? Is it broader or narrower? Whether it is turned inward or outward? So these things can help us identify whether we are looking into a male or a female skeletal component. Okay, right. Let me take the help of this video. So this video, and bear with the music. Music, I don't know, for some reason I didn't like the music so much in there, but don't worry. I think they nicely analyze in different angles how the bones look like. I'm going to pause and tell you what points to write. Okay, we'll once go through the couple of points and stop it there. Then you can make a couple of points from that. So here the subheading should be this: in forensic anthropology, we're talking about how do you determine the gender of a skeleton. We are trying to reconstruct the information here from what is available to us. So first component we are dealing with here is determining the gender or sex. Okay, right. So let's see how do we do that. We know I'm playing the video here. For some reason, if it is not playing, okay, if you're not able to hear, do let me know. Okay, open your mic and speak.
is about the differences between the male pelvis and the female pelvis.
Are you able to hear the voice? Can we just confirm once quickly? Are you able to hear the voice and video is clear?
Yes, sir.
Great. So we are looking into the female and male, okay, pelvis here. Right at the bottom it is males and this is females. Let's have a look at few points and I'll pause there and make note.
Pelvis. So to start off with, we're going to look at the pelvic inlet, which is ascribed by the pelvic brim here, and it is larger in a female than it is in a male.
Okay, so what are we learning here? So we are looking into the pelvic inlet. So this is the pelvis and this is the backbone, where exactly the spinal cord actually attaches here. Okay, this is the tail part. So this is the back side of the pelvic region and this is the front side of the pelvic region. Okay, and we are looking into what is called the pelvic inlet, the opening of this pelvic region. We're looking from the top here. We're looking from the top. So how is a pelvic inlet different between males and females? Okay, make a note of this. So we are looking into the skeletal differences. The major one that we are looking into here is a pelvic region. Differences in pelvic region is what we are focusing on to understand the differences. How is it different? So first we talked about pelvic inlet. We're talking about pelvic inlet. This is the boundary between the pelvic cavity and abdominal cavity. Abdominal cavity comes on top of this, right? For abdomen and then pelvic region. So here this is the kind of opening that we are noticing. How is this pelvic inlet?
And the female pelvis. So to start off with, we're going to look at the pelvic inlet, which is ascribed by the pelvic brim here, and it is larger in a female than it is in a male.
So pelvic inlet is larger in females and relatively smaller in males. So if you want, compare it, right? Like a table, males and females. On the left hand side, write down, we are talking about pelvic region and the first subheading is pelvic inlet. Pelvic inlet. Pelvic inlet. Okay. Draw a table, females and males. Females and males. Inlet is larger in females or broader in females and relatively smaller in males. Not sure if it is really visible to you here. This is more broader compared to this. This tends to be slightly, smaller in females or in males. In females, it tends to be wider. So more wider or larger pelvic inlet in females and relatively smaller in males. Okay, right. Like that, I'll show you a bit of this and I'll let you know what to write. So we move on like that. Wherever you are unsure, do stop me. I'll repeat it. Okay. So moving on. Right. So female pelvic inlet more broader or more open and circular. Male pelvic inlet narrower. And also you kind of see this. This is like heart shape because the coaxial, or we normally say the tailbone part, comes inside, inward. So because of this appearance, it looks like heart-shaped structure. Female pelvic inlet, open, circular, more open and circular or broader, as I already told you, broader and circular. Male pelvic inlet is narrower and heart-shaped. So a few differences if you write for each of these components, that would be sufficient in understanding the role of these components in forensic anthropology. Okay, next.
Now, when we look inside, we can see the curve of the sacrum and the coccyx is in a man is much more anterior than a woman, where the curve is straight down.
So what are they talking about? The backbone region when it actually joins this part that we have seen, the coccyx, okay, the tailbone part that you normally see, the extended bone part that you normally see, in females it is shorter and it's more or less straight. As you see in this image, it is not coming in the middle. Imagine that we're talking about the part which has to facilitate the process of delivering the baby. So there should be nothing obstructing this path. So that is what you notice here. Of course, you see a portion of this sitting at the end, but usually from the pelvic inlet region, you don't see much of this tip region of that bone. Okay, this is called sacrum. So female sacrum is shorter, wider, and less curved. There is no curvature. It is not going inward. It is more or less flat. Whereas in the males, what do you see? If you push something, if you push the baby to the male pelvic inlet, it will come in middle. What happens? Male will definitely experience a fracture of this region. Even in some complicated surgeries, complicated deliveries, sometimes females may lose this portion of the bone. Fracture may happen in this if the baby is too big. Okay, so but males' body is designed in such a way that this coccyx region that you notice here is inward, curved inward. There's a curvature. Whereas in the females, it is not curved or less curved. It is not at all. It's not completely flat. It looks more or less flat. Less curved is probably the safer word to say here. So it is not completely like this, but maybe like this. Okay, if I'm showing it from this side, in the males, you see this bone is actually curved like this. So the tip can be seen from the top of the inlet, as if it is going to touch the baby if baby is going through that. Whereas in females, it is not inward like this. It is not curved like this. It is like this. Not totally flat, but less curved. Okay. If you see it from the image, it will become a bit easier for you. This is the region I'm talking about. Can you see from the image here? Okay, this region I'm talking about. In males, there is more curvature to this region, and in females, there is less curvature, more flatter. Okay, understand the concepts, write down the terms. Okay, when you repeat it, if you don't understand, I'm going to share this video links with you. You watch it. Okay. I'm repeating this, what I've just shown you. This very short videos, 2 minutes videos, 2 videos that we have. So not too bad.
Now, when we look inside, we can see the curve of the sacrum and the coccyx is in a man is much more anterior than a woman, where the curve is straight down. Also, the ischial spines in a woman point posteriorly, whereas in the male pelvis, they point medially.
So what are we talking about here? Underneath the inlet, if you're going down in the inlet portion, there are few bony structures. These are called ischium spines or ischial spines. They're spelled like this here, ischial spines. So what are the ischial spines? You see the bone regions. Okay, if I can show you from the PowerPoint slide. So these regions, these tip-like regions. Not sure if you're able to see it. These regions here, like they're like sharp tips. Okay, towards the bottom. Inlet is on the top, right? We're talking about the bottom side of that. There are few, spikes of bones. They're talking about the angle of these bones. Angle of these bones. These are called ischial spines. Don't worry, make a note of the term. You will remember some of these. Okay, these are called ischial spines. So in female, ischial spines are project less inward. So they're not coming inward. So they're not, again, obstructing the path. Okay, female ischial spines project less inward. Male ischial spines project more inward. So they are more coming in the path, as you see here, whereas they are more away from the the pata from the center. Okay, so what do you write here? Ischial spines is a subheading for that. In the pelvic region, ischial spines, they project less inward in females, they project more inward for males. More inward, less inward. More inward in males, less inward in females. Okay. Ischial spines more inward in males, less inward in females. Okay, I'm repeating this.
Spines in a woman also, the ischial spines in a woman point posteriorly, whereas in the male pelvis, they point medially. In the anterior view, we can see the subpubic angle, which is this angle right here. And in a man, it is much more narrow. In a woman, it is much wider.
So what are they talking about? They're talking about in the front. So this is the back. So far we focused on the surrounding here, back region here, and the projections in the center, in the middle, right? So we are now looking at the front portion of the pelvic region. Okay, these are called subpubic angle. You'll write it. First listen to me, okay? Subpubic angle. So they're talking about how is this angle is in males and in females. Females, it is more broader. In males, it is like more narrower. This angle is actually low. And in females, it is actually more broader. That is what they are saying here. Listen to it again and make a note of it.
Which is this angle right here. And in a man, it is much more narrow. In a woman, it is much wider.
So female subpubic angle is more wider. So what do you write on the side? Subpubic angle. If you want to draw a small diagram, or else I'm going to share something that is labeled like this. Our video is anyway there. Subpubic angle is a subheading there. And what do you write? In females, it is more wider. Okay. And in males, it is more narrower. If you want to draw the diagram, draw this diagram. Show this pelvic region and just show that. Put a triangle like structure. Don't have to draw the structures. Just show that they are close by. You put a triangle, close a triangle like this. Pelvic region, you show it like this. Subpubic angle, you put a triangle like this, which is narrower in males. Same thing for the females, you put more distance between these angles. Okay. So like this, narrow in males, like this in females. Okay, this is subpubic angle. Okay. Narrower in males and wider in females. Let's move on.
Now we're going to take a lateral view.
They're showing the side view now.
So the greater sciatic notch is here, and it is much wider.
Look at this part. This is male part. Do you see how this, coccyx or this tail region, the spinal cord is coming in the middle, right? Look at in the females, how open it is. It's actually not inward. It's like this. Whereas in the males on the side, it is very clear. The males cannot deliver babies because of this reason. The bone comes in the path. Their pelvic region is not designed to deliver the baby and carry the baby. Whereas females are designed like that. Okay, right. So we'll see what they're talking about at this angle.
So the greater sciatic notch is here, and it is much wider in a woman than it is in a man.
So what are they talking about? They're talking about something called sciatic notch. They're talking about sciatic notch. If you see from the top, slight like spacing that they talk about here, that he was pointing out from the center. Okay, basically, more or less, what are we seeing here? It's more wider in females and more narrow or shallow in males. This is the overall theme that we are learning with respect to the pelvis region, right? In females, majority of them are actually broader and no curvature inside outward. So they're providing enough room for the baby to come through that region. Whereas in males, it is not the case. Okay. So why are we learning about these changes, these differences? So by looking at them, we can identify whether the pelvis belongs to a female or a male. So biological differences, morphological, physiological differences that we are looking at, mostly structural differences so far that we are looking at to identify the differences between males and females.
And they have the thumb test, where if you place your thumb in the greater sciatic notch, in a male pelvis, it will be tight, whereas it will be loose in the female pelvis.
So yeah, I think this is not needed. Basically, you feel it's more crowded in the male system. Female system, it is more relaxed up. There is more space. That is what they're talking about. But these differences that I told you so far are sufficient. Okay, could you follow those differences? I felt these videos are better to show you and make you understand. I'm going to share these videos with you. Okay, you can watch it to get an idea. But can you describe these much? Is it too complicated for you? I understand terminology you have to repeatedly use. Make a note of them. Some of these will come back, will again revisit. Okay, but some of these, if you can just remember a few points, if not all of them, couple of them. So we talked about multiples of them, and you might have got about 4 points on this. Okay, if you can write even 2, 3 of them, depending on what they're asking in the question, this should be sufficient. Okay, so overall structure-wise, this is how it looks like. So bony structure, several parts. Coccyx is the one that I was showing you, the tip of the bottom. This is sacrum. This is sacrum region. This is coccyx region that we have seen in the video. Okay, we are going to talk about a bit more on this pubic symphysis. For not now, we'll just ignore it for now. We'll come back to this. This is also very useful. Okay, so this is how it normally should look like. This is spine. Okay, so this is based on determining the gender based on pelvic region. So moving on, how else can we determine the gender? So second option is looking at the cranium, looking at the skull. So skull also shows variety of different or variety of differences between males and females. There is enough sexual dimorphism, meaning there's sexual differences between males and females that you can use to identify them or distinguish them. So what are the differences? What features of the skull are we going to use to differentiate them or to identify whether the given skull belongs to a male or a female? By looking at, would you be able to tell? If so, what features do you use? Okay, let me explain that few of these things and what differences are there, again using a video. So second subheading should be, yeah, if you're writing in the table, you just write another subheading. We are going to use a skull. Cranium or skull it is called. We are going to use what are the differences in the skull that help us identify whether it's a male or a female. Okay.
Sex differences in the skull. There are no sex differences until puberty. The post-pubertal differences are as follows.
So what are we learning? I think puberty is where we start noticing the major sexual differences between males and females, correct? So there are not many such differences that you find before puberty, but they are more visible to us after puberty as post-pubertal. Okay, so basically we're learning the puberty is the time where we start noticing more differences between males and females.
The weight of the skull in males is heavier and in females is lighter. The size is larger in males and smaller in females. The capacity is greater in males.
So for each of those things, I'm going to actually stop to tell you what to write, as we have already done. So we are analyzing some general features of the skull. So what did they tell you so far? They're comparing here. This is on the left-hand side, it is males, and it is right-hand side is the females. Do you see? This is more robust and more larger. The male's skull is more robust and larger, and females is relatively smaller and lighter. That is what they're talking about here. So what do you write down? Skull weight of the skull. So in males it is heavier, in females it is lighter. So large and heavier in males, relatively smaller and lighter in females. So however you wrote, if you started with females it is smaller and lighter. And here they are heavier and larger. So these are the two differences that you have to make a note of here.
The weight of the skull in males is heavier and in females is lighter. The size is larger in males and smaller in females. The capacity is greater in males and it is 10% less than that of males in females.
So we learned quite a bit about this in unit 1.6, where we are going to learn about the fossil fuels of humans. From chimpanzees or other primates to humans, the brain volume or the capacity of the brain has changed. So the size of the brain, basically we are referring to size of the brain. What is the capacity of the brain? It is not the qualitative. We're not talking in terms of quality here or functionality here. We're talking about the size of it. So normally they say brain volume. So what is the capacity of this? So the capacity of it, usually we are on the range of about 1250, 1300 cc, we normally say volume wise. About 1300 cc, we normally say 1200 to 1300 cc, right? But even within that, we have a difference between a male and a female brain size. So what are we learning here? It is greater in males, and we compare, this is on relative note. Okay, humans do change or are different from many of the other primates like chimpanzees and gorillas. But within us, we are talking about the differences between males and females. So more greater volume of the brain in males, or you can use the word capacity in males. Females about 10% less. So about if you're talking about 1250, so 125 cc less. So it is mostly on the 1100 or 1200 region. About 100 cc, 125 cc difference we're talking about. Okay.
The walls of the skull are thicker in males and thinner in females.
Rajashekhar, I hope you have written down the previous point. Okay, heavier in males and greater in males, greater capacity or larger brain volume relatively, about 10% less brain volume in the, okay, in the females, slightly less in females because the size is small. Next, they're talking about thickness.
The walls of the skull are thicker in males and thinner in females.
Talking about how thick are these walls. Okay, male seems to have thicker walls in the skull, whereas female seems to have relatively thinner walls. So thicker, thinner walls of the skull, the surrounding of the skull basically. Okay.
Muscular ridges, glabella, superciliary arches, temporal lines, mastoid processes, superior nuchal lines, and external occipital protuberance are more marked in males and less marked in females.
First of all, don't get scared. Too many terms, right? We don't have to remember or write about all of those terms. So what are we noticing here? There are more marked features or more clear features are found in males compared to the females. So we'll make a note of one or two of them. Okay, don't have to write everything from that. I'm going to show you some of these, but they're very quick on this. I'm going to just pause and we'll write few of those points. Other skeletal differences, skull differences in males and females that we're going to look at. So if you notice that they're actually highlighting things as they're talking about, they're highlighting various regions, but it's too quick.
In females, muscular ridges,
They're talking about various the regions that protrude out or stand out, like muscular ridges. So the elevations that you see because of muscles on the face seems to be more prominent or more marked in males. So muscular elevations or muscular ridges are more prominent.
glabella,
So glabella. So these regions that you are seeing here, highlighted here. So this region.
superciliary arches, temporal
So don't worry, these regions here, this is called superciliary arches.
lines, mastoid processes,
They're saying temporal lines. Not sure if you've heard about this, is called temples, right? You know about temples, right? So these lines, this temporal line seems to be more marked in males, less marked in females. If you want to write, you can mention about the temporal lines, it is called.
temporal line,
Temporal lines. If you want to make a note of this, more marked muscular ridges, if you want to write one of this, more marked muscular ridges in males, less marked in females. So you say muscular ridges on the subheading, less marked in females, more marked in males. Okay, and these temporal lines that they're pointing towards, these temporal regions that we have certain lines here. So those temporal lines are more marked in males, less marked in females. Okay, these 2 points from this screenshot is enough.
lines, mastoid processes, superior nuchal line,
So mastoid process. Mastoid process. If you touch just behind your ears, you will find this bone structure. Just put your fingers underneath the ears. You will find this bone structure. This is called a mastoid process. So this is the region you see. This is the ear, just behind the ears. This bone is called mastoid process. So more marked. You say mastoid process. You can write down as a hint that bone just behind the ear. The ear flap that we have behind that, this bone is called mastoid process. Same story, otherwise more marked in males, less marked in females. Mastoid process. Okay, moving on.
mastoid processes, superior nuchal lines, and external occipital protuberance.
Right. So don't worry about superior nuchal lines, but we'll focus on the protuberance. You actually feel your backside of the head. You move your hand like this at the backside of your head. Okay, because of the hair thickness, sometimes you may not feel it too much, but we normally, when we shave our head, you can feel that at the back of your head, you see some sort of protuberance, okay, or some sort of uphill region here. That it actually has a curvature like this. You see a little bit of elevation at the back of your head. That is called protuberance. Occipital, because in the bone skeletal system, this is called occipital region. At the back, if you hold your hand like this at the back, occipital region. So we have an external occipital protuberance. Touch it here, it kind of elevates like this. That region is called protuberance. And this protuberance or elevation is more marked in males, less marked in females. So it's more flatter. In female head region, this protuberance is more, flatter. This region is more flatter. In males, it is more marked, more elevated. So external occipital protuberance is called.
are more marked in males and less marked in females. The tympanic in females. The tympanic lines and external occipital protuberance are more marked in males and less marked in females. The tympanic plate is larger and the margins are more roughened in males, and it is smaller and the margins are less roughened in females.
So what? You can ignore this because we don't need so many details like this. So we're going to ignore. We're talking about tympanic plate is a kind of a bony region in the ears, not behind the ear, within the ear itself. So don't worry, we're going to ignore that. There are more points that we can write from this.
The supraorbital margin is more rounded in males, while it is sharp in females.
So we're basically talking about the orbits. So eyes are sitting in this bony structures, right? So this region that we normally have, if you touch it here, so our eye sockets, we normally call them, right? So eyes actually sit in there. If you see how the margins are here, so they're comparing the margins here. So these margins seems to be more rounded in males and more sharp in females. So more sharp, rounded, so more curvature basically. They're talking about more curvature here, less curvature here in the females.
Margin is more rounded in the
They're called
supraorbital margin is more rounded in males, while it is sharp in females.
So supraorbital margin should be your subheading. They are more rounded, more curvature, and then more sharp here. Okay.
The forehead is sloping or receding in males. It is vertical in females.
So this point is, I think we revisit this point many times because in many fossils, our ancestral fossils, we look into how this region is. Okay, we're talking about forehead region. Look how forehead region in the males versus in females. In males, what you notice is sloping or receding, gradually curving. So it's gradual curvature you notice an average in the male, forehead region. So what do you write? Forehead region. And for males, it is sloping type or receding type. So written females first, it is vertical, sharp curvature or sharply it is going down. You can draw a line like this. You see the difference in the line here and the line here. So this is called sloping type. Remember this. We are going to revisit this in several of our fossils or ancestors that we compare this. So this seems to have changed over a period of time. So it's more receding or sloping, whereas in males, whereas in females it is more vertical forehead. So this is what it means. If you want, you can draw a simple diagram like this. I'm going to show you some diagram ideas for unit 1.6. You can take hints from there, but otherwise show a quick drop in the curvature here. Quick drop. Okay, here you just put a circle like this, gradual drop. Okay, this is one difference that you can easily remember.
Males. Frontal and parietal tubercle are less prominent in males, whereas they are more prominent in females.
So if you actually touch, so you see here just above your eyebrows, you'll find what is called frontal or parietal tubers. These prominent, sometimes they're called. Okay, so it's less prominent. You don't see much of the gaps here or difference here in the males. So they're less prominent in males, more prominent in females. Okay, frontal and parietal tubers they are called. So the gaps or spaces you normally find when you touch here, these are less prominent in males, more prominent in females. Opposite to what we are talking about, because more or less what we talked about so far are more marked in males, but here they're more marked in females. They're more prominent in females. Frontal and parietal tubers are less prominent in males and more prominent in females.
The vault of the skull is rounded in males, and it is somewhat flattened in females.
the overall vault or overall shape of the skull you notice here. If you draw a line, it looks like more rounded like structure in males. And here, this curvature is not there. This curvature is missing because beginning with the forehead, of course, you don't find that. It actually quickly goes back here, looks more or less flatter. Okay, so we're talking about the vault of the skull, more rounded in males and more flattened or less rounded in females.
Contour of the face. In males, it is longer due to greater depth of the jaws. The chin is bigger and projects more forwards. In general, the skull is more rugged due to the muscular markings and processes, and the zygomatic bones are more massive. In females, the facial bones are somewhat smoother, and mandible and maxillae are smaller.
Okay, don't have to write all these points again. I'm going to just quickly tell you a few of them. Like for example, chin. Okay, they talked about overall contour of the face and chin. I think chin is something easier. More bigger jaws, a bigger chin in males and smaller chin in females. That should be sufficient here.
Due to greater depth of the jaws, the chin is bigger and projects more forwards.
So bigger chins. So chin should be the subheading. Bigger chin in the male, smaller chin. So bigger and broader. You see it is big and broad. Smaller and more projecting type of chin. And normally the nature of the chin is projection. It should not be massive. Remember how a chimpanzee or gorilla looks like they have a massive jaw like this. You can hardly see the chin portion for them. Because once this face became more flattened, humans started showing the chin region. And within us, we have more bigger, broader chins in males, smaller and more protruding type of, or more sharp chins in females. This again vary. We're talking about a general picture of it, okay? The smaller chins and bigger chins, smaller and pointed versus bigger and broad.
In general, the skull is more rugged due to the muscular markings and processes, and the zygomatic bones are more massive.
So this is up to you if you want to write. So if you feel these bones underneath the eyes, these bones that you normally see here, this bone region that you see, this is called zygomatic bones. These are called zygomatic bones. Okay, highlighted in the blue or purple or whatever you're seeing here. They're massive.
And the zygomatic bones are more massive.
So in males, these are more massive. They're more bigger, basically larger. In females, they're small. So zygomatic bones, bigger or larger or more massive in males, less massive or smaller in females. Okay, I think we've seen enough differences in skull. You don't have to write all of them. Look at the points. Remember 3-4 points from that, whether you want to talk about the flatness of the forehead, you want to talk about the protuberance part, okay, or you want to talk about the roundedness of it, you want to talk about the chin region, you want to talk about the zygomatic bones, it's up to you. Or you want to talk about the prominences here. Okay, check. Okay, right. I know they're a bit complex, but hopefully you could follow them. Okay, and see the differences in them. Okay, right, guys. So this is about utilizing now determining the gender using two components. We talked about pelvic region, then we talked about the skull. These are the two major things that you have to know with respect to determining gender. So based on this information, one can identify the gender. Okay, then we'll move on to the age determination. After gender determination, how do we determine the age? So how do you know the age of the skeleton? The different ways, I think one, we can look into the growth rate of bones. Growth rate of bones can roughly tell us the age of a given individual. Okay? Bone growth, rate of the bone growth. How far did the growth happen in the bone? So specifically observing the bone part, I'm going to briefly tell you about that. Different regions in the bone, how well they developed. I think bone growth seems to go through multiple stages. By looking at the stage of that bone, one can roughly estimate what age that skeleton could be. What is the age of that skeleton component? What is the age of that bone region? So growth rate of bones can help us identifying or determining the age. Growth rate of the bone. So observation of bones, study of bones can help us. Okay, either we look into ossification or a fusion process. Different stages of the bone, one can look into different stages of the bone growth. They can look into ossification process or bone development process or fusion process, because we are all born with over 300 bones, but they come down over a period of time. Approximately the number of bones reduced by 100. Where do they go? They don't disappear, but they fuse to form bigger bones. So fusion is one process. Fusion also age dependent. So you can actually look into the fusion process and utilize it or use it to estimate the age. Okay, when bone development process and fusion process. When bones develop or fuse. So ossification process and fusion process. Ossification is a bone development process basically. You can ignore this osteons. The osteons are few structures found in the bone. Observing those osteons seems to also help in determining the age, but we focus on more general picture of this. Plus, not only this bone structure, I think I'll briefly tell you about that. So like this is a bone structure. In the embryo, bones are normally seen like this. You see this blue color regions here, these are cartilage regions. So what normally happens, bones starting to develop from the center, they go towards the ends. So then what happened, this blue color region is squeezed. You notice the difference between these three diagrams? As the bones are developing, this blue color region is diminishing. So bones replace cartilage regions. These are the end regions. Remember, more fresher like structures. Okay, and these, as we age, the region of this containing this cartilage decreases in the bones. They are the ends of the bone squeeze, whereas the center of the bones expand. Okay, so determining the length of this. In the embryo, the length of this should be larger. And the young person, the center part should grow in proportion to the external regions of the bone. So they normally refer it to as growth plates. They call it growth plates. In adults, they reach the maximum bone growth. There is no more room for growth here because it hit the blue color region. So whereas if you have more blue color region, meaning it can extend further. Blue color region indicates the extendable region. Okay, so like that, in young people, you normally notice that this blue color region decreases and the center region increases. And in adults, the blue color region is more or less, not much is seen, or very, very minimal, whereas the center region that you can see here. So depending on the growth stages, you can observe this and you can explain what could be the approximate age. We're talking about three complete distinct ages. I'm going to tell you briefly other bones that we can use in the process, but in embryo, it should look like this. In young people, it should look like this. In adults, they should hardly find any of these blue colored regions. So depending on how well the center region grew and how minimal is the final regions or the terminal regions, one can approximately estimate the age of that person born, age at the death. Of course, they don't grow after death, right? So at the time of death, what was the age of approximate age of this individual, male or a female, and what should be the approximate age? This is all approximation. Accurately, we cannot determine this. Okay, I'm skipping some terms here, like it's called diaphysis in the middle. This is called metaphysis. This is distal epiphysis. Will be a little too much for you to remember. Okay, I provided a general idea that how bone growth happens from the centers to the ends and how the end regions would decrease over a period of time. And the amount of end regions that you have can give us an estimation about what age that we are looking at. Okay, right. So towards the end, I'm going to talk more, but most of the most commonly used bones for determining age include teeth. We're going to give examples of this. We already talked about teeth in growth chapter. So teeth, how many teeth are present? What teeth are erupted? What teeth have not erupted? Milk teeth versus permanent teeth. They can help us identify the ages in the early stages of life. And big bones of our body, like either humerus talk about, or you can talk about femur. So thigh bone and also this bone, arm bone, thigh bones, femur, humerus. Okay, and I'm going to tell you a few more later, and something called pubic symphysis I'm going to talk about. But what are the most common bones that are used here? Teeth and bigger, larger bones like femur and humerus. Skull, anyway, I told you, cranium. Otherwise, these are the ones. Okay, how? I'm going to give a rough idea on this. How do we use the bones to determine the age? For ages between 0 to 5, ages ranging from 0 to 5 years, teeth provide us the best clues. Teeth provide us the best clues. This is called forensic odontology. This is called forensic odontology. So teeth are the best sources for us. Okay, we already discussed the ideas on the teeth, right? We know it. The timing of the teeth eruption, we already discussed about when do the canines come up and when do incisors come up, the age of eruption, age of shedding we talked about. So this timeline can be used to check approximately whether only these teeth are seen. So the baby could be of age of about 1 year. Okay, any of these things, or about 1.5 years. If you are seeing first molars and second molars, we're talking about 2.5, 3 years period. And again, whether they are milk teeth or permanent teeth, you can approximately estimate whether the baby is of, or the skeleton belongs to someone between age of 6 to 10, 10 to 12. Okay, roughly they will help us giving the clues. Whose body are we looking at and what is the approximate age? Right? So you can apply this knowledge by looking at teeth, by observing teeth to approximately estimate the age of this baby. And usually they are better for something between 0 to 5. If you're talking about permanent teeth, below 10 years of age, approximately. Okay, but of course, wisdom teeth would also help you, which normally appears in the in youngsters, so basically in adolescents, early, like about 18 years to 22 years approximately within that time period we notice. Okay, so wisdom teeth can also help you. Okay. Otherwise, 6 to 25 years, for ages 6 to 25, the fusion of bone ends to the bone shaft. I was showing you these regions, right? So ends, normally we have some gaps here. So the fusion between these regions are helpful here. Fusion of bone ends to bone shaft. Epiphyseal fusion varies with sex and is typically completed by age 25. If fusion is complete, you know that person's age is at least 25. Okay? The fusion process, epiphyseal. So we talked about the distal epiphysis region is this region. If there is a fusion of the shaft region to that, that indicates that the person is about 25 years age. Okay, but these bones are of not great use for ages between 25 to 40. So below 25 years, these type of measurements and clues are useful to us. About 25 to 40, not much happens to bones. There is not much you can learn because the bone growth has almost attained the maximum. Okay, there's not much change happening in the bone structure. So 25 years to 40 years of age, bones are of not great use to us for estimating the age. And after 40 plus, what happens? We start seeing the wear and tear on the bones. What do you notice here? You start noticing the wear and tear on the bones. Like arthritis problem, you can see breakdown of pelvic region. Okay, or periodontal diseases that we sometimes hear, periodontitis that we frequently hear nowadays. So these are specialists who can deal with some of these bones. So some wear and tear, over usage, pain in the joints would show you the clear indication of rupture or damage to the joint regions, joints. Arthritis is that, joint pains and damage to the pelvic region. Okay, and other bone related, density related problems that you may notice here. I'd like to show you here briefly. Yeah. So occupational stress wears at the joints. You see it here. So joints may damage. Sometimes what happens? Maybe because of the occupation that people are on, people are into, how much of strain that they are actually putting on the bones, the joints. So some amount of wear and tear. It could be occupational or age related. Age related is more relevant here. Occupational may kind of misguide us. Although the body looks like more damaged, more used, maybe because of the nature of the work that they do. Okay, plus some accidents, surgeries or healed wounds. You see it here, surgery. There was a rupture that you can notice here. They joined this bone region. So those type of things can be found, damages, accidents. They had an accident on the right hand side of the leg. This bone actually got fractured. You can see rods in the body, or you can see those joined parts in the body. So like wear and tear plus accidents and surgeries that might have happened indicates normally the age factor. So because our bones become less and less stronger over a period of time, and they are more prone to fractures. So unless accidents happen, that actually tends to tell us about the approximate age. We may estimate that they had big bones. Could be malnourishment or also could be the age factor. Okay, so we can use these clues. Okay, what else? So length of the bones can also be used. Something really simple. The long bones that we have in the body. What are the long bones we have? What is the longest and strongest bone in the body? Is our thigh bone, femur. The thigh bone is the longest and strongest bone in the body. Femur. So femur as well as humerus. Humerus is this bone. So femur is the thigh bone. Humerus is this bone. So this bone. These are the long bones in our body. We can approximately, by measuring the length of them, look at the length of these. By measuring the length of this, because as I was telling you, the growth, bone growth will differ with age for up to certain age, right? About 25 years. So by measuring the length of the bones, we can approximately estimate the age as well. The measurement of the long bone compared to the standard examples for specific ages. What is the length of this and what should be the approximate age for a given length of that bone? So charts have been made, reference tables are made. Based on that, they can approximately estimate the age of the person based on the size of the bone. But the limitation here is they're mostly suitable for children and pre-adolescents, about 25 years of age. Not much happens here. So it's only useful for that time range. Okay. And anthropologists, together with the help of archaeologists, okay, and other specialists, can help you determine even the stature, nature of the body as well. So long bone, already told you, femur, humerus, like, is proportionate to the height. Okay, so their length approximately tell us the overall height of the person. Okay, so we can estimate approximate height of the person. There is a ratio, so there are formulas for this. The tables that forensic anthropologists use. So depending on the race, it may change, but there are certain tables, standards that they use in this concepts. What do they get? They get approximate height of the individual. How do they get it? By calculating or measuring the humerus length, measuring the length of the humerus. And also they can actually calculate like this: height equal to 2.89 into the humerus length plus 78.10 centimeters. Don't have to by heart this, just showing you an example that by measuring the length of these things, there are formulas that are made by measuring many well-known objects. So approximately estimating the height of these individuals. So it is possible to measure the length of the bones and approximately estimate the height of that individual. Okay, but of course there are inexact or they're not exactly specific. So there's variation. We get rough idea on this. Okay, what else? So the next one is the sutures. Sutures. Okay. So what are sutures? Sutures basically, if you see the skull region, this we're looking at the top of the skull, this region that we are seeing here. So there are few gaps like structures that you may find. So sutures are like junction regions. So we have bones here like this, but when we are born, we need enough flexibility. So we have certain gaps, or normally we see junctions. Between two bones, we may see a junction like this, like what you see here. This is a junction, this is a junction, this is a junction. So these junctions are called sutures. Junctions between adjacent bones of the skull. So to provide enough flexibility when we are born, when we are coming to the mother's pelvic region, there is a flexibility. You can squeeze the head a bit because there is a little bit of a room for squeezing. So this is very useful to provide the flexibility during the birth. And those sutures take time to close. They're not needed anymore further, right? So slowly they close. So by looking at what sutures are closing, we have an idea how much time or at what age normally they close. They can approximately estimate this. They can approximately estimate. For now, just write down. I'm going to give you a few points for you to write. Sutures are junctions between adjacent bones of the skull. Sutures are the junctions between adjacent bones of the skull. That is what you see here. There are many such sutures. You are seeing sagittal suture here. This is at the back, you call what is called lambodial, and this is called coronal. Not corona, not related to corona. It's called coronal, lambodial, and the middle is called sagittal suture. So there are many sutures. So timing of the sutures can help us determining the age. Timing of closure of sutures, if you want. Timing of closure of sutures can help us determine the age. So I'll let you write down a few points on this. 2 or 3 points, just to know how sutures can be used. Yeah. Okay. So for example, I think we'll start with one that happens very early. This is something called metopic suture in the front. This is the front side. So this region is called metopic suture. Write down metopic suture. When does that close? Okay, so this runs in the frontal bone part of it. So this closes between 3 months to 9 months time. When you go to doctors normally observe it here. They touch it here and feel. You take the infant to the doctor, they start observing this region. If you have any child, a small child or infant in your home, touch it here. You can actually feel the gap here, this part of the head. This closure happens between 3 months to 9 months time approximately. The closure happens between 3 months to 9 months time. This suture should close by about a year, so between 3 to 9 months. So this tells us an approximate age below 1 year. Similarly, I was talking to you about coronal suture. So this suture, coronal suture. This begins to fuse by age 24. So starting from about 24 years of age, it's beginning to close, but normally the closure finishes between 30 to 40 years. So what does it mean? If you observe the skull, if coronal suture is closed, it indicates that the person's age is above 40 approximately. So you know approximate age from whether the suture is visible or not. Okay. So metopic suture closes between 3 to 9 months. Coronal suture closes between 30 to 40 years. Last one I would like to tell you, sagittal suture. Sagittal suture more or less matches with coronal suture. Sagittal suture is this. We learn about sagittal crest. In some of our ancestors, there's a very strong muscles here. Sagittal crest it is called, this region here. It's like, kind of extended or elevated region that you see here. So this matches with sagittal suture. It may not completely close, but it usually closes between 30 to 40 years of age. Okay, but very difficult. Long range for it, sometimes even after 50 years, it may not close. But at least it gives an idea that if it is starting to close, the person is maybe at least in the age of 30 to 40 years and more. Like that, by looking at the gaps between these bones, one can approximately estimate the age. Okay. Good. Right. Normally, we notice that so there is a male and female differences you also see in bone growth. Males, normally we attain peak bone mass by the age of 25, 20 to 30 or 30 years like that. Okay, we maintain more bone mass. If you actually look into the females, females actually don't attain so much of bone mass like males because of the physiological nature, and they also lose the bone density because of menopause. Bone loss can happen due to menopause, and normally we talked about menopause, right? So this hits about 40 to 50 years of age, where there's a lot of loss in their bone density. So these bones not only can be useful for us with respect to determining age, some gender differences can also be understood from that because of the inherent differences that we have in males and females related to that. Okay, so what is the key point here? The bone density differences, marked differences between males and females. In males, peak bone mass is attained here approximately with more overlap, and more bone density can be retained, in males, whereas females lose most of the bone density after menopause. So age. So how is the bone density is changing before and after the menopause? Approximate age can help us estimating the age here as well as the differences between males and females. Okay. What else? Okay, just briefly mention about this. I think I was talking to you this what is called pubic symphysis. So this joint that you see, where two bones in the front are meeting, this is called pubic symphysis. And I was telling you, between the ages of 25 to 40, very difficult to use the bone structure, right, for estimation. But one clue or a key region that changes during this time, this age, where we don't have too much clues from the other bones, I'm talking about 25 to 40 approximately, we can use this pubic symphysis, changes that happen in pubic symphysis. Okay, middle and older ages can be determined within a range by changes in the pubic symphysis. Okay, so the joint that's commonly used in estimating the age within this time frame is pubic symphysis. What do you notice here? From 18 to 90 years, 20 to 21, 20 to 24, 25 to 26, so on, 30, 35, 30, 40, 40, 45, like that, for up to 50 years, there are certain changes that take place within this pubic symphysis region. Especially what happens, they exhibit wear, they may become more flattened, and sometimes even they may get curved. The differences that you are noticing here, they can also help approximately estimate the age. And where is this useful? It's mostly useful between the ages of 25 to 50 approximately. Okay, the region where we don't have too much clues available otherwise. Okay, so these are the various components that we can use in order to estimate the age. And before that, I talked to you about the gender. Okay.
Sir, how do they find the difference? They all look the same.
Yes, I think it's more like how doctors, for example, can identify by touching your bone. So this requires some experience, but we have reference points for it. Like for example, look at the width of this versus this. These are more narrow, and here they're more broader and shorter. Look at the curvatures, for example. So here you can see, because there are more specific changes that seems to happen in the curvature related to that. I believe they probably measure a few specific regions in these parts. Okay, and compare it to the standards. So I think for us non-specialists, So these are more or less invisible, but definitely you can see the difference in the broadness. They're more narrower, they're more broader here, and ruggedness. So it's actually more or less nicely flattened. Here there's a lot of ruggedness. You see lots of various components here. It's more rugged, not uniform. Here, more uniform nature, nearly edges of our life. So those components that we can see, I think more specific details archaeologists or anthropologists can figure out, or forensic specialists can figure out. Okay, but for now, if we can write between the ages of 25 to 50, joints, changes in the joints such as pubic symphysis are of use, or they can use them by comparing with the references, they can estimate approximate age, okay, which is not obvious to us for sure.
This is only applicable for males, right?
These are not necessarily. I think the image that I'm showing here is just a sample that I have shown you here, but this could be for others as well. Okay, we're talking about the case with the white males. So difference points exist for, I think, the different ethnic groups and different genders. So this is just a sample of that. Okay, like I already talked about. And next we are coming to the end of this like ancestral part. What are the differences would you look for? Age, gender, specifically we talked about here. Ancestral. Who do they belong to? What type of features they have? What type of ethnic group they are? So anthropologists can also attempt to identify ancestry of skeletal remains of the body. So what do they do to determine the ancestry? They look for specific skeletal features. Because different ethnic groups or different races have certain distinguishing skeletal features. In the next unit, we are going to talk about that. In the race concept, we are going to briefly talk about what are those differences that we have between Mongoloids, Caucasoids, etc. Okay, so those differences that they're going to look into to identify the ancestry so that they can identify the specific race. So we discuss more in race class in the next session. So today I'm not going to talk to you in detail about that, but just you know that Mongoloids, their eye orbits, sockets are different. Okay, their overall shape of the skull is different. Negroids, they have more prognathism, more protruding jaws that they have. Okay, Caucasians have more longer noses, for example, longer faces, for example, or skulls, for example. Okay, like that, some certain skeletal differences that we can use to identify whether it has features of a given race. Is that a Negroid or a Mongoloid or a Caucasoid? You can identify that based on specific features. What are those features? I'm going to discuss that in the race class, in the next session. Okay, so we can identify the race and ancestry. That is what I want to tell you here. How you can write few examples once we finish that other unit. But I gave some examples already here. Prognathism or protruding jaw in the Negroids. Mongoloids, eye shape, for example, the overall structure of the skull. Caucasians also, the length and geometry of the skull. Certain indices that we have to use, I'll explain that later. Okay, so these things that can be used in identifying the ancestry. So next, the other question that we would like to answer is the time of death. So far we identified the age, gender, race. What is the time of death? How do you know that when did they actually die? What is the death, approximate death time? Okay, so there are different ways that they can determine the death, the time of the death of that individual. Something like temperature, body temperature is routinely used for this. How our body temperature, because we are warm-blooded animals, we maintain our body temperature when we are alive, right? But what happens once we die, our body temperature slowly, we lose our body temperature. We cannot maintain it anymore. It gets equilibrated with the environment. It becomes as much as the environmental temperature. Okay, but it has to be done early. We're talking about first several hours of the death. Then temperature is of great use to determine approximately since how long the body was cooling down. The temperature of the body can be used here, especially for the first 24 hours. The core temperature, as I was telling you, falls gradually with time since death. As we die, you won't be able to run the metabolic reaction, so slowly body starts to cool down and temperature comes. And of course, it depends on many factors like body mass and fat distribution, and what is the ambient temperature for that region. So these factors may differ here, but overall, you can approximately estimate whether this dead body is lying here since last 3 hours, 4 hours, 6 hours, like that. And especially this is useful only if body has not come to the equilibrium within that time frame. So approximate age estimation can be done by looking at the temperature. There's a timeline for that. I think 3 hours, 4 hours, like that it goes. So time and temperature variation. The next routinely used one is called rigor mortis. What is called rigor mortis? So what is rigor mortis and how do they use rigor mortis to estimate the time? Okay, so rigor mortis refers to what? Rigor refers to stiffening of muscles of mortis. Mortis means dead body. So stiffening of dead body's muscles is what it refers to. Rigor mortis refers to. So what do they normally say? If body is starting to feel a bit warm and then eventually body becomes more stiff. The first in 3 hours body still feels warm. Okay, and it's not as stiff as it would be after 3 hours. From 3 to 8 hours, what happens? Body feels a bit warm, but it is becoming stiff. So as the time passes, stiffness of the body increases. Okay, and further on, body starting to feel cooler. After about 8 hours of time, body starting to feel cooler and becomes more stiff. And it depends on, there also seems to be an order of events. They say eyelids, lower jaw, and face becomes stiffens first. That is why normally they close the eyes immediately or in few hours. Otherwise, what happens? You cannot close the eyes because the muscles lost the flexibility. Because muscles require energy, right? No energy production is happening. The leftover energy can be used to move the muscles. But eventually, what happens? No energy, so they'll become too stiff because no availability of energy. So we cannot close it. So like that, eyelids, lower jaw, face stiffens first, followed by which muscles of the back of neck and trunk. Trunk region, back of the neck stiffens next. Then muscles of the abdomen and lower limbs part stiffens next. Like that, there is an order. So depending on the order, depending on whether it is still feeling warm, what part of the body is stiff, they can approximately estimate the time of death. Okay.
It is only done on the body, no inner sample is taken.
No, not necessarily. We just basically feel the body's temperature. Maybe they feel even the temperature of the blood. Okay, no invasive methods are required here. I don't know whether they would really care because postmortem is done anyway. Right? So during the postmortem, they estimate it. It's not like they can approximately feel the warmth by the warmth of the blood. One, okay, or by touching the body. Second, whenever they conduct the postmortem, I think they would. I don't know exactly more specifically on where do they take the temperature, what parts of the body, but they have access to all these body parts anyway during the postmortem. So they might use those samples to determine this process. Otherwise, I think by feeling the warmthness of it, blood, by touching the blood, they may be able to get a feel for it. But more thorough analysis was done during the postmortem. Okay, before 24 hours, after 24 hours. But what if body is actually not collected within the 24 hours? Let's say body was left somewhere else in a jungle. How do you know that when was this killed? So they would look into the decomposition of the body, right? So if that is the case, they would look into the insects that are growing in the body, basically decomposition process they would look into. So it looks like the presence of insects in the dead body provides great amount of clues. Presence of insects, their life stages. See how biologists use this. The stages of life. Insects, what life stage they are. Because a certain stage, egg stage, larva stage, moth stage, like the insects go through certain stages. And there is well-defined timing for that. The body is sitting like that, you estimate the approximate stage of the insect, thereby estimate the time of death. Since how long the insects are living on that dead body. Okay, because flies rapidly discover a body and their development times are predictable. Okay, of course, in relationship with the environment. Okay, So flies are several insects starting to live on our body, starting to decompose them. By observing their stages, one can approximately estimate the time of death by basically counting back from what state or stage are these insects in. Okay, I don't think we need details, but in this example, they briefly talked about forensic entomologists, specialists studying insects. They could approximately calculate the larva and the stages of the larva. Okay, but of course, it also depends on what temperature is it. So temperature can determine the growth speeds as well, right? Air conditioning buildings, warmer climates may have a different ranges here. I think those things will be considered. But these are the ideas of determining the time of death approximately. So we're coming to the last part of the discussion here, reconstruction. How do you reconstruct? So based on the, so far we talked about determining the gender, age, various other factors like a time of death that we talked about. So how do you reconstruct it? How do you reconstruct the body? How do you reconstruct the facial features? This is a very generic idea. So anthropometry is very, very useful here. Study of fossils is very, very useful here. Study or better understanding about the human skeletal system is very useful here. So human anatomy and anthropometry plays a very important role in this. So measurements of different features are normally taken. If you found the skeletal system, they have to take certain measurements, which overall define the shape of the body, shape of the face, for example. Measurements of different features are taken. Then musculature and skin put over the skull for some reconstruction. On this, they're starting to apply, they're starting to use, I think I'm going to briefly talk about 2D printing, 2D, 3D analysis can be done on this. So basically they're starting to add a little bit of components. Okay, like muscles, skin is briefly added to these parts. Whether computer programmings are used and some amount of physical reconstruction is also done for this. Okay, so they're starting to fill these regions through measurements. Specific measurements are needed which can help them basically fill the places like this. Then based on this, one can sketch. Others use drawing of head based on skull measurements and formulas. So what do? We can even use computer programs or sketching. So roughly draw based on these features, these dimensions, one can approximately figure out what should be the face shape and details about the facial features. Like that, they can match of John Doe made after someone recognizes him. John Doe is a, I think, term that normally used related to unknown people or unidentified people. Okay, so matching this unknown person with someone with those features. Okay, these are the features probably belong to so and so person who was missing. Of course, other clues are needed, so they can reconstruct the face like this and overall getting the idea about what should be the actual face look like, approximately looks like. We see normally this in the movies, right? How do they utilize this? But for this, there's a lot of technical or technological advancement as well. So for the forensic facial reconstruction, we not only use anthropometric measurements here, okay? They're going forward with something like 2-dimensional and 3-dimensional techniques. 2D and 3D techniques are applied in reconstructing the faces. So this 2D, 3D structures either manually done, as you see here from this, you see using programs, they could approximately estimate or try out different hairstyles, different facial structures to get to an idea about how this skull would have looked like with the skin and flesh on it and the hair on it. So approximately they can create this. So 2-dimensional techniques or even 3-dimensional techniques, better depth, better details that we obtain from 3-dimensional techniques, which are more advanced than 2D. There are many software programs that have come which can help you estimate the details in various parts of the body. Like that, using 2D and 3D techniques, one can reconstruct the face from something like this to from something like that. So for 3-dimensional facial reconstructions, okay, they use sculptures. So they use cast of cranial remains. So these are the cranial remains. They can use it, they prepare a cast on it. They actually apply, certain material like cast material. What happens when you apply, depending on the specific dimensions, that material gets stuck to that. So the extra amount of material would go off. So approximately with the cast, they can create image with these features that you see. So this should correlate with what the body dimensions are, what the skull dimensions are. They're created with modeling clay. They use some sort of clay for this, which is called modeling clay, and other materials. They use modeling clay and other materials, and with 3D reconstructions, you can get high resolution information and high resolution computer images you can create. Okay. For this, forensic anthropologists play a very important role. Along with forensic anthropologists, artists also play an important role. Like that, what we are seeing here is a physical reconstruction, okay, modeled with a specific material, casting material here from a skull. Like that, facial reconstructions can also be done. Right. So with this, we briefly talked about forensic anthropology. What is forensic anthropology? What do we deal with it? And how anthropometry specifically help us figuring out many of these things. How physical anthropologists with the understanding of anatomy, human anatomy, how do they help identify the gender as well as the age and various other factors, including the reconstruction of the face. So this is the forensic aspect of our applications of anthropology. Okay, with that, we finished talking about Unit 12. So any questions you have on this? Is it clear? Are you able to follow what I discussed today? Okay. So I know this is a bit complex in terms of terminology, but otherwise, a brief idea. I'll show you briefly the type of questions that have come in the exam related to this in the past. So from Unit 12, what type of questions had come? Would you be able to answer those questions? Let's have a look at that. So questions are like this. Anthropologists' inputs in facial reconstruction. What are the anthropological inputs in facial reconstructions? Short note question. What is the role of anthropologists? So last part that we talked about, what are the different stages and what is the role of anthropologists by providing the measurements related to the various body parts, plus of course, artists use and also softwares are required for reconstructing it. So briefly explain the process and tell where do anthropologists contribute to it. So basically looking at the skeletal region, specific dimensions of the skeletal components, okay, and how that can be utilized to create a model, okay, of that person, and along with the certain features like hair components, etc. So this question had come in 2019, 10-marker question. And next, what are the methods of personal identification? Critically examine how personal identification helps in criminal investigations. So what are they asking here? How do you identify a person or an individual? 20-marker question came in 2017. What are the methods of personal identification? Critically examine how personal identification helps in criminal investigations. So we talk about various methods that we talked about. We discussed about identifying a person, gender, age, and identifying the DNA. You also talk here about the DNA fingerprints or DNA analysis, genome sequencing analysis also you can mention here for specific details, identifying the individual based on the DNA. Otherwise, gender determination, age determination, etc. Okay, what else related to this part? Forensic anthropology short note came in 2016. Just forensic anthropology. You talk about what is forensic anthropology, what is the role of physical anthropologists in dealing with the crimes, starting from all those components that we discussed today. A brief summary of it. Okay, what is DNA technology in medicine can be taken from Unit 12 or that. Otherwise, forensic science can help in criminal investigations discussed. 2015 question. Forensic science can help in criminal investigations. That is why I wanted to have enough idea on these components that I discussed with you. Okay, you discuss about the role of anthropology in the forensics with examples of this. Okay, what else we have? Personal identification came once. Role of forensic anthropology. Okay, role of forensic anthropology in field of personal identification. This question is repeatedly coming. One question came, role of anthropology in solving medico-legal problems. You talk about these legal issues, basically talking about forensic issues. You can also talk about paternity disputes, etc. in that. Otherwise, identifying the person who died in the incident, okay, criminal investigation. So DNA fingerprinting you talk about, and these components you talk about in that. So role of anthropology. This is most repeated question. I think one old question that I have noticed is specifically focused on applications of knowledge of human osteology in forensic investigation. This question came like this. So keeping that in mind, I've given enough idea on this component. Briefly discuss the applications of the knowledge of human osteology in forensic investigations. So bones, how do we use bones and bone related things in forensic investigations? So you talk about those age determination, the criteria that I've given you. We discuss about that. Okay. Otherwise, what questions have come? 2012 also we have question on application of anthropometry in designing that we discussed in the last session. Anthropometry in design, and elucidate the role of anthropology in selection and monitoring of sports persons. Role of anthropology in sports that we discussed in previous sessions. Designing equipment came thrice in the exam. So designing equipment, sports had come multiple times in the exam. Otherwise, I have not seen much of it being asked on the nutritional anthropology, and what else we discussed about the design had come, sports had come. Nutritional anthropology questions I have not seen. So it is very much possible. But otherwise, on the design process and sports anthropology, mostly forensic anthropology, where questions kept repeating. So what I discussed today is very, very important in the exam point of view. Otherwise, DNA technology in medicines, so reproductive biology, serogenetics, cytogenetics have not been asked so. Okay, so these are the type of questions that you can expect. Are you comfortable in answering these type of questions based on our observation? Okay, I hope so. Okay, great. This is where I want to end the session. I'm going to announce it on the group. Venkat Mohan sir said that he's going to take tomorrow's session. I think he's going to wind up the classes. So he's going to take, I think, 2 sessions tomorrow. So you won't have my session in the evening. So I will take on the day after. And if sir's slots are also full, after talking to you, I will briefly discuss with you. Okay, but otherwise, I think we finished unit 12 now. So in 9.5, I'm going to briefly talk to you in the next session. 1.5 session, we'll finish 9.5. With that, we'll move to the last unit, primates and fossils. Okay, so we'll finish majority of it this week. I think I may need 1 or 2 classes maximum to wind up the rest. We'll see how much we can do this week. Okay, right. So thank you guys. I'm going to end the session here.